Today we are taking a look at the speed upgrade kit for the newer bounders. I believe this applies to most of them that go back about 2 or 3 years, but you may have noticed recently that when you order a bounder, it comes with a kind of standard off-the-shelf control system, either RNet or dynamic links. But what we're going to look at today is how to install the kit, and also if it's something you should even be considering, because there are a number of things that will affect your decision when it comes to taking the chair up to 11.1 to 11.6 miles an hour. Now, Bounder offers a number of different speed upgrades and different speed levels that you can get depending on your chair, the user's weight, configuration, and things like that. However, there is one prerequisite that you have to have before any of this is possible. You have to have ordered the chair from Bounder with their high-speed 8.5 mile an hour package. If you have the 6 mile an hour setup, none of this is possible. They actually use different motors between the 6 mile an hour and the 8.5 mile an hour setup. So if you have the high-speed setup, it is possible in some circumstances to make the chair even faster. So assuming that you have the chair that was delivered with the 8.5 mile an hour high-speed package, and you have a DME that's willing to make modifications to your chair, then that DME can order these parts from Bounder and install them. But again, you cannot order this directly from Bounder. 8.5 miles an hour is as fast as you can go when the chair is delivered from the factory. But they give you options to go faster if the conditions are met and it's something you want to do. I will say though, there is definitely something great about being able to go, 11 or 12 miles an hour in your power chair. Yep, definitely fast. Another thing you need to know about this setup before you go changing out any sprockets or making the chair faster is this will 100% affect your ability to climb hills, and in some cases the range of the chair a little bit. Now, I have the 100 amp hour lithium iron phosphate battery in this chair. I'm assuming this is possible with the lead acid batteries. Those are going to add a little bit of weight as well. So if you live somewhere where there are any hills and you have to deal with those on a daily basis, I would stick with the stock configuration. The 8.5 mile an hour one can handle hills no problem whatsoever, and you're safe with that. One other thing I should mention is there are definitely weight limits to each one of these different speed levels that you can install. And trust me, you do not want to be over those weight limits, because overheating your chair is pretty much the only way you can damage it. Other than that, these things are pretty indestructible. But with all that out of the way, there's going to be 3 halves to this video. This part here where I'm kind of explaining what's going on, then we're going to install the kit, and it takes me set up, and I've worked on Bounders a lot and I have all the tools and everything, but it takes me about 20 to 30 minutes per side on the chair. Obviously filming that's going to take a lot longer, but that's the second half of the video. And then the third half of the video, we're going to go out and do some testing, and I will give my final thoughts on the setup. But if you have any questions, feel free to leave them down below, or reach out using the contact form or the other contact information in this video description. As per usual, I'm going to talk about a lot of stuff. I'm going to make a second abbreviated version of this video. A link to that will be in the description. That's going to be geared towards DMEs or people installing this. I'm going to try and keep it down to 5 or 7 minutes at the most maybe, and it's just going to rapid fire through all the steps. But in typical style, I'm going to talk about a lot of stuff. I'm going to give my thoughts and opinions on things, and we're going to just basically install this, and hopefully you enjoy. Okay, we're going to start here by taking off the tires. I have the foam-filled ones installed on here. If you have the air-filled tires, you want to be very careful and make sure you completely let all the air out of the tires, completely deflate them before you touch any of these bolts. These are split rims, and if there's air inside there, there's pressure pushing the 2 halves of the split rims apart. And if you start taking these off, you could have, well, we'll just say you're not going to have a good time. So I'm just going to go around and loosen these all a little bit by hand. I'm just basically turning them until they get loose and then moving on to the next one. If you do decide to use power tools on this, you just want to avoid taking one bolt out all the way. You want to still do this sort of circular procedure. There should be a washer, a lock washer, And I like to always use anti-seize on these things. Pull this off of here. If you look here, you can see that the center of the tire and the wheel have kind of pushed out a little bit. The foam filling on these definitely does create some outward pressure. When we go to put these back on, there's a trick I'm going to show you using a longer bolt to make that work, because right now, if we try and push one of these bolts through, you can see right here that there isn't really enough sticking through to engage with the hub. Next up, we're going to shift our attention to the brake cover here. But on my chair, this is a 5/32 Allen cap bolt, so just use an Allen wrench or something similar. And there's 4 screws we're going to pull out all the way around here. I believe there's a spacer behind here, and I think you can just kind of take these part way out, just kind of loosen them, and I think that spacer may hold them in place. So I'm just going to back these out a few turns. Now, at the time this particular chair was built, these levers were 3D printed. I'm not sure if they're still doing that, but you pull out the single screw and then you can kind of gently slide this off at an angle. You can see that lever there is not straight up and down. So just take the screw out, should slide right out of there. It is PETG, so it's a pretty solid material. Okay, let's try that. There we go. Yeah, so in the up position, you just kind of lift out the bottom, and then that lever will pop through the hole there. And you should be able to see all of the dirt inside here. But we've got some little spacers right here on each side. And it's kind of nice. You don't have to back these out all the way, and it sort of captively holds your screws in place. So this covers all one piece, and it's our dirt. And yeah, pretty nice arrangement. Next up, we're going to pull this brake off of here, and there are four hex cap screws, 2 on the top, and 1 down here, and 1 on the front. Let's say it might be better to use my Allen sockets for this. Yeah, let me grab those real quick. All right, 5/16 Allen socket here. Once again, I'm just breaking them loose, and then we'll pull them all out. Now at this point, you want to make sure your brake is in the locked position, probably before you even take these screws out, because there's a disc inside there that interfaces with the actual brake itself. And if this is in the unlocked position, it kind of moves around and makes reassembly a little bit more obnoxious. Actually, I don't know. They changed a few things on here, so that may not matter necessarily. But we're gonna unplug this. For right now, I can't reach the connector, so I'm just gonna set this right here on the wheel out of the way. Next, we're gonna come around to the front of the chair here, and I've tilted the thing back a ways, that way I have access to all this easily. You may notice I don't have a factory horn on this one. I'll leave a link down below for this, but this is a 24 volt, 150 decibel dual tone air horn. And let me tell you, it's every bit of 150 decibels. And it's actually not too hard to mount it in here using some of the existing hardware. But what we need to look at is right down here. This is our automatic chain tensioner, and we need to loosen this. This is a 1/2" nylock bolt right here, so we're going to use the deep socket for that. Then I'm going to reach around behind this and hold on to the adjustment nut behind this. That way we don't try and turn anything out of the heim joint that's back here. So I'm just going to kind of hold that in place. And then we're going to loosen this up a ways. And by loosening it up a ways, I think I mean we're going to take it all the way off. For this, we have a single nylock. Then we've got a couple of washers there as well. And we'll pull the spring off. And now you can see this mechanism here for the automatic chain tensioner is now loose. Now with this loose, I'm going to go back around to the other side, and actually here, if we just push on the motor right now, you should be able to see that the motor moves freely. Let me go over to the other side and I'll show you that a little bit better. Now, I'm not sure if Bounder recommends that you take this cover off and clean inside here regularly, but it's definitely something I'm going to be doing, simply because you just get a little bit of dirt and stuff in there. It's probably fine, but whenever we have chains and stuff moving around, I prefer to keep those areas clean. Okay, so we've got our chain tensioner basically loose over here. Now we can grab this motor and kind of rotate it down a little bit. And by down, I mean kind of in a backwards direction like that. If I can get a good grip on it. There we go. So this is now tilted backwards. Ever since I got this chair, I like to keep around pieces of cardboard like this, because when I'm cleaning and lubricating the chains occasionally, it's nice to have something to catch all the dirt on. But as you can see now, our chain is nice and loose, seeing as how we've rotated that back. And we can go ahead and pull this right off of here. Looks like I'm about due for another cleaning of this thing. And here's our rear hub, and here is our front motor sprocket. Just for reference, they do have documentation. Oh, that's all blown out, but there is documentation that shows this process. I'm going to put a link to that down below. It's just kind of a broad overview and tells you about some of the spacing and steps and things like that. It doesn't go into great detail, but you know, if you're a DME or a shop, this is pretty handy to tell you what size parts and grub screws and things should be here and how to set everything back up properly when you're done. Because the spacing on this motor output shaft here is pretty critical for a lot of things. So this is a keyed motor output shaft. You can see that machined into the motor shaft here. There's a keyway, and then we have our key. Then this gear here on the outside is what interfaces with our brake mechanism. And you can see that right here. When the brake's in the locked position, that doesn't move. I'll go ahead and unlock it. And now you can see that this moves freely and can rotate in here. This brake mechanism is designed to clamp onto this part here and interfaces with the motor output shaft. And when this is locked, the mechanism clamps down, and now this won't move at all. This being a fairly new chair that has not been exposed to the elements and is not multiple years old, these components should slide off of this shaft with no problem. But as things age and you're running through the rain and the water and everything else, there may be a little bit of corrosion or rust or something like that that's going to prevent these from sliding off. So to get this off, I believe there are 2 set screws. Yes, there's one right here and another one right here. These should be 1/8 inch. So we're going to put this wrench in here, break that loose, go 90 degrees, break this one loose. I don't need to take these all the way out because I know this is going to slide off of here with no problems. If you do need to use a puller or something like that, obviously be careful, but using a puller on this is perfectly acceptable. But this will slide off here like so. Closer look at this, you can see our keyway there, and then we have the 2 set screws that hold this on. Then our actual gear back here is going to be a similar setup. It uses a 5/32 Allen wrench. This one may be a little bit tighter, so we're going to get a wrench in here and break that loose. Actually, that wasn't bad at all. Rotate 90 degrees. I'm going to back these out a ways, just till they're about flush with the outside. That way I know they're not going to be interfering with removal. Now this top one here, and same with this gear, actually pushes right down on the key stock that goes in here. So that's a really nice design aesthetic, as it were, to keep things from rattling and hold everything on there nice and solid. And actually, if you look real close, you can see there's the ever slightest amount of rust on there. So that's something that's going to happen, but as you're lubricating your chains and using the chair, I mean, some of that's probably going to get down in here. But once again, if you have to use a puller, it's not the end of the world, and it is something that they mention in the documentation that's acceptable to do. Also, when you tighten down the little grub screws, they put little marks in the key stock, so sometimes sliding this off might be a little tricky. I'm going to see if I can carefully get this key stock out of here first. Yeah, there we go. Just pulled that out to make it a little bit easier. And you can see here that there are a few marks in this key stock that I was talking about. If you can pull it out, just be careful with it. Don't bung up the edges and everything with pliers, but it might make it a little bit easier to slide everything apart with that out of there. May not come off without a puller. I'm going to rotate that just a little bit. There we go. Come on. There we go. And likewise with grub screws, you're going to get some marks in the motor shaft as well. So rotating that ever so slightly was able to get me past these little marks here on the motor shaft. It's probably good to use a little bit of lubrication or something like that as well if these things are really stuck, just some penetrating oil or something like that. All of this stuff is pretty stout, but it's best not to apply unnecessary force on all of these parts if you can avoid it. Okay, now that we've got everything completely disassembled here, we're ready to swap out our motor sprocket. Now, this chair is the high-speed variant that you can order directly from Bounder, and on the front, it uses a 21-tooth chain sprocket on the motor. Now, I'm doing the 11.5 mile-an-hour mod on this thing, which I'm technically over the weight limit for, but I'm just doing it for demonstration purposes. So, we are switching from a 21-tooth gear to a 23-tooth gear. And if we put them back to back here, you should be able to just kind of barely see the size difference here. And with gears like this, the tooth count is what makes all the difference, because the tooth spacing stays the same, and the more teeth you have, the bigger the diameter gets. So if you look at the two of these, you should be able to see the difference. This is the smaller one, and this is the larger one. Now, putting everything back together here, getting the spacing set just right is very critical. And this is where the little data sheet that has all of the specifics on it is going to come in handy. Once again, that is linked down below. So I'm going to get the motor shaft rotated around so our keyway is near the top, just for ease of purposes or whatever. And the part of it here that has these marks in it, I'm going to put that facing down just to aid in kind of putting all this back together. So we will slap that back in there. Then we're going to slide our new gear on here, and the big part, like this hub here, sticks out. Let's make sure that our grub screws are backed out all the way first. Yeah, those look fine. So let's go ahead and slide this on here. Now, obviously, being a chain drive, you can't have this touching. You gotta have room for the chain. But if you have it out here too far, then it's gonna cause an issue. So the instruction sheet shows that you need a 7/32 of an inch gap. And they mentioned a really genius way on here how to measure that gap. Get yourself an Allen wrench that is 7/32 in size, and that's how you set it. Now, I don't have any of the little tiny, like, pocket-sized bendable ones, so I'm just gonna put this right against the motor plate here, and I'm gonna make sure that the handle on this is not touching. Pull this out a little bit. I'll make sure this is completely flat. So looking at the Allen wrench, you can see we've got a few flat surfaces. So I'm going to make sure that it's flat up against this backing plate here. Get it all the way over here. I'm going to kind of hold it in place with my thumb here, and then push this back just till it contacts. And there we go. We have our gap set properly. I'm just going to hold the entire thing. I'm going to come in here and tighten up this first grub screw. Honestly, having those little tiny right angle Allen wrenches would probably be a better way of doing this. And my hand is kind of blocking the view here a little bit. Yeah, that seems pretty good. It fits in there a little snug, but I think we should be okay. I'm going to stick this chain on here just to kind of eyeball it. Oh yeah, nothing's rubbing. Looks good. Then we don't want to forget to tighten up the other one. And then snug that down so it doesn't move. Then I always like to check the other one just to make sure we're good. That seems fine. And you just want to get those, you know, somewhere between snug and good and tight. I did, however, just notice something on this sheet, and it says to use blue Loctite on all set screws prior to reassembly. Now, I'm going to be taking this all back off of here again and changing a few things because I'm testing out a bunch of stuff. So I'm not putting Loctite on these right now, but if this is the configuration that you're going to leave it set up as, definitely put a little bit of blue Loctite on there because you do not want these backing out. Again, not going to have a good time. The last piece we need to install here on the front is our little brake engagement gear. Actually, what do they call this? They call this the brake hub. Now we obviously need to get this in the right spot as well. If it's too far out, it's going to interfere with the brakes. If it's too far in, we're not going to get full engagement. So how do you figure that out? Well, it says in the instructions here that you want 0.44 inches from the end of this to the face of the gear. Luckily, Bounder has a little 3D printed tool for this purpose, I mean, you could just get out the micrometer and, you know, use the depth gauge function. Micrometer, that's not the right word. Calipers. Most calipers have a built-in depth gauge function, but they have this little 3D printed tool, and they sent this over as well. One other point of note is you want to make sure when you're putting this key stock back in there that you leave it far enough out to fully engage with this. It is possible to put this key stock all the way in the back, and then there's not going to be enough of this hanging out here in the front for full engagement with this. So let's put this on. Then we have our little tool. We're just going to press this on. And we pull our gear up flush with that. And you can see there's just enough key stock sticking out there to have proper engagement. Now we can take our 1/8 inch Allen wrench. That's a lot of syllables. And get this tightened down. Pull our tool back off of here. And once again, somewhere between good and snug and fairly tight. Just don't put a breaker bar on it and stand on it. And there we go. Now everything should be spaced properly. Just for no reason, I'm gonna go grab my calipers real quick and we're gonna double check the measurement of this thing just for no reason. I don't know if a lot of people realize, but most calipers like this have a depth gauge function built in. Now these may look really fancy, but these are just some cheapo ones from Amazon. However, if you open them up, see how I have this plunger that comes out of the back? That's a depth gauge. So let's pull this all the way down, make sure it's zeroed. There we go, and we wanted 0.44 inches. And the way we're gonna do that is just put to the edge of this on the end of the motor shaft, and then push our depth gauge down to about there. Then I'm gonna lock this. So let's see, inches. There we go, 0.45. Close enough for government work and within the margin of error of how I did this. And their 3D print, I think you can see this. Their 3D printed tool is 0.405, so that's not bad. Now, just because I'm a weirdo and I want to check this other measurement, I have the gear from the other side here. So let me zero this out. We're going to measure the thickness of this. Then we're going to zero it out again. And we wanted 7/32 between here and there. So I'm going to put this zeroed out thing on. Going to push it out that. We'll put it in inch mode. And oh, it just moved. There we go. It's just alternating between 27 1/28 and 7/32. So there we go. A little bit of sanity check. We can make sure everything is how we thought it should be. Sure enough, it's showing 7/32. By the way, I'll throw a link to this little caliper set down in the description below. It's from Amazon. The cool thing is it does millimeters, fractal inches, you know, so fractions of an inch in decimal form, but it also does them in actual fractions, as you can see there on the screen. So it's kind of a handy set. The actual fraction display is not something I've seen on a lot of these, but anyways, I'll throw in an Amazon associate link to this down below. It doesn't cost you anything extra, but I make a small percentage on the transaction. I'm legally obligated to say that. Next up, in the 11.6 mile an hour conversion kit, we need to swap out our rear sprocket. But as you can see, the sprocket is behind the hub, which means we got to pull this entire hub assembly off of here, which isn't necessarily difficult, but involves a little bit of screwing around. So let me get reset up here and we'll take a look at how to do that. For the next part, you're gonna have to pull the battery box out. And I actually just built this little wooden thing out of a bunch of 2x12s. They were free in a free wood piled bin at a hardware store, so 2x12s aren't really necessary, but it worked out in my case to be able to hold the chair up. But if you throw a jack or something under there, you just have to make sure that there's room to slide this battery box out. Otherwise, you won't be able to get to the bolts. And obviously the wheels are not on the chair, so you gotta have it jacked up. And I've got the camera pointed at the other side, but when you pull the battery box out, you can see the wheel over here on the other side, right here. But what we're gonna be looking at is right down here. You can see this nut right here. And that is a lock nut that holds the giant bolt that the hub assembly attaches to. We need to take that lock nut off, and then we can unthread the entire hub shaft assembly. Now on my chair, that is a 15/16 bolt. My old bounder that I got, I don't know, the one that's probably 8-9 years old at this point, also used 15/16. So I'm pretty sure that's going to be the right size. Now you're not going to have to hold anything on the outside because the entire assembly is threaded, and that is literally just a lock nut. Okay, so that is fairly tight. All right, for the life of me, I cannot get that loose. So we're gonna try the quarter drive impact. And if this one doesn't work, I have another slightly beefier one. I don't know if this is recommended or not, but it's what I'm doing. I think. Did it come loose? It did! Look, here's the nut. Okay, so that is very tight. I apologize if you're not supposed to use power tools for this, but a quarter drive impact is not really strong enough to mess things up too insanely. But anyways, here's what I'm calling the lock nut. It's, in this case, kind of used as a jam nut, and it actually goes on and off of here very easily. I can just thread it back on with my fingers, no problem. Back out here on the front side, there's a little cap here you should be able to pull off. Now that we have the lock nut or the jam nut off on the inside, there's a very long bolt that goes all the way through here, and it's threaded. And if you notice, the hub turns around this and the bolt does not turn, which is nice in our case because unlike a car, if you were trying to turn on that, well, anyways, whatever. So let's see if we can get this off. I'm just gonna do the little palm slap. There we go. And the entire hub, as you can see, will come off with this bolt. So just kind of pull it out and you can hold it. There you can see our giant golden grade 8 bolt that goes all the way through, and it has the bearings built into this hub assembly, and the whole thing just comes off. And there is a spacer in here, so you don't want to lose that. And now, to change out the gear, all we need is an end wrench and a socket, and basically just take these nylocks off. These 3 bolts are going to come out of here, and then our gear will come right off. Obviously you want to be very careful because this is like a giant cheese grater for your hand that's sharp. And I've thrown some cardboard down on the ground to kind of keep from damaging the gears and whatnot. But I like to go around and break each of these loose. Then for the purposes of expediency, because these are long bolts and nylocks are kind of annoying to deal with, we're going to use the impact just to get everything off there. So I will just hold this. Now we can stand this up. The ice maker is going to make ice maker noises. Then we can pull each of these bolts out of here. They may require a little bit of persuasion to come out. And the gear pops right off. There is probably going to be a spacer underneath there, so you want to be careful not to lose this. If you look at the hub, the surface of it is not completely flat. So we need the spacer on here, well, one, to get the chain into alignment with the drive motor, but also it goes up past that little centering ring there and allows everything to bolt down nice and flat. So do not forget this part. And on the 8.5 mile an hour setup, the rear gear is 70 teeth. To go all the way up to 11.6, combined with that new front gear we put on there, we're going all the way down to 60 teeth. So if we look at the difference between these two, you can see there's a fairly substantial size difference. Now on the driven part of a chain drive, smaller is faster, and on the driving part, bigger is faster. So we have increased the front gear tooth count, and we are decreasing the rear gear tooth count. This is going to be a significant upgrade. Look at that difference. That's pretty substantial. Putting this back together, just make sure your spacer's in here. There are a number of holes here of different sizes. And this application uses the larger of them. So once you get this on here, you just want to make sure you've got those. So we'll just plonk this down on here like some sort of weird sandwich and get our bolts pushed through. Then we're going to go around and add our lock washer and our nylocks to each one of these. And I'm going to use the impact to just zip them most of the way down, get them close to where they need to go, and then I'll finish tightening them off by hand. I know I keep saying it, but you got to be really careful when you're working around chain drive sprockets like this. They are extremely sharp, and if your wrench slips off and you bust a knuckle on one of these, well, it's not going to be pretty. Now I'm going to leave the tightening of this up to you. You can see that this is the main drive sprocket, and this needs to be very tight. Once again, don't use your breaker bar and stand on it, but you want to make sure these are as tight as you can conceivably get them by hand using normal size tools. If you're using a 2 or 3 foot long one of these, obviously you can snap the bolts off. So stay within the margin of what grade 8 hardware can handle, but you want this to be very tight. And by the way, as long as the nylocks are still in good shape, there's no reason to use Loctite on any of this. We do have lock washers and nylocks, so everything there should be fine. So I'm just going to make sure we don't have any dirt or anything in there. Should be fine. Kind of inspect our threads here, make sure they haven't been damaged. And we're going to slip this back in here. Then I'm going to start this by hand. Get it a good number of turns on there. And then we'll zip it back into place. Then using approximately the same amount of force that I did when I took it apart, I'm going to do the old ratchet and palm trick to get this tight. And I'm going to check this again later as well. But as many of you know, working with your hands and tools and bolts, if you have any experience, there is a feel to that, and you can tell when it's as tight as it needs to be. Again, the whole thing is threaded when it goes in there, and then we're going to add this lock nut on the inside. All this you want to be really tight. And if this is in there in place, everything should be fine. I don't know if Loctite is recommended on this or not, but honestly, if you're never going to take it apart again, at least on this, it wouldn't hurt to maybe put a little tiny bit in there. If that's incorrect for some reason, I'll pin a comment down below about it. But if you're never taking it apart again, it probably wouldn't hurt to put a little bit of Loctite on this, what I'm calling jam nut that goes on the inside. This is just a regular half-height nut, but it's used in sort of a locking fashion, as you were. I was just getting ready to move the camera and go around to the inside to put the lock nut on, and I saw our little spacer. So this has to come back off. Hopefully I didn't damage the bearings in the process. I think we're okay. This kind of redirects the load from this machine surface here to the proper spot on the bearings. Also, obviously, it changes the alignment in such a way that the chain's going to line up. But if you look way down in there, I think you can see that that just provides a little bit of a wider surface for this to mate to instead of pressing directly against that bearing. So let's put this back on again. Then I'll get this tightened down and we'll go around to the inside and get that lock nut put on. I just realized if I put the camera over there, I can kind of show this lock nut going back on. There's a bunch of stuff in the way and I don't know if it's focused, but this goes on right here. So I'm just gonna put that on by hand. Then I'm gonna come in here with my ratchet and get this tightened down. Again, I'm going to leave setting the proper torque on this up to you to do it as you see what is proper and fit for this application. I'm going to be taking this all back apart again in a couple days because I'm trying other stuff. Oh, there we go. Now you can see. So I'm not putting this back together in a permanent fashion. Like I said, otherwise I might put a little tiny bit of Loctite on that. Alrighty then. Now our rear sprocket is changed out, and so is our motor drive sprocket. So let's go ahead and throw a new chain on here. Typically when you're changing out the different sizes of sprockets, you're going to need a new chain that is of the appropriate length. We have a new chain here that vendor sent me with all this, and it says it's 49 links. Let's see how close that gets us. Well, what do you know? 49 links is exactly right. And for reference, this is the 60-tooth sprocket on the back and the 23-tooth socket on the front. So let me throw a couple of new master links in here. And by a couple, I mean one, obviously. I'm going to be doing this on the other side as well, but I will probably do that off camera. And it is installed. Now we can move back around to the front of the chair and get our chain tensioner all sorted out. All right, we got our chain tensioner stem sticking through right here. I'm going to grab the motor, pull it forward. Then we're going to stick on our spring and a couple of washers and our nylock. And we'll get this tightened down. Now I'm not sure what the actual specification is for how tight this goes, but what I'm doing is just setting it so that the amount of this stem that's sticking out right here is the same as the other side, and also what it was when I first took it apart. So I'm going to reach over here and squeeze the chain a little bit. Yeah, that feels good. So yeah, I think this side is good to go. Back around to the side here, now we can get our brake mechanism reinstalled. As you remember, I had this sitting on top of the tire. Well, I moved the chair and this wound up falling off and unplugging itself. The connector is way down in there, so we're gonna have to deal with that later on. But like I was saying earlier, see how this is loose now? It's not gonna be quite centered all the way, so I'm just gonna leave it in the unlocked position so this moves around. If you did leave it locked, you're probably good. But if you do have any trouble getting this put back on there, you can unlock it to give yourself a little bit of wiggle room. But what we need to do is mesh this collar with this gear right here. So we're just gonna kind of stick it on here, move it around a bit until that goes on. You can turn the motor shaft a little bit to aid you in that. There we go, that's clunked into place. Now we're gonna line up these little ears here in the top. And as you can see, everything kind of moves around. If you thread your eyeballs way down in here, you're gonna see that these mounting holes are conical shaped. And what that allows us to do is use these tapered head fasteners, and it'll allow everything to line up. So we want to put these in one at a time. I'm just going to start with this one, put it in just a little ways, and then this one here. Then we're just going to turn them until the taper just barely starts to touch the bracket. That's going to allow everything to line up the way it should. And then we'll get the other two in here. Going to give this thing a little bit of a shake as we tighten that up. Just turn them slowly in. We're not trying to tighten them at this point, we're just trying to get everything centered. And then at some point you'll notice it quits wiggling around. And you're good to go. Now you can go back around and torque all of these, which I'm going to do with the socket Allen. And we'll just get these torqued down to the appropriate amount of tension. And it sounds like my upstairs neighbors just got home, so it's going to be extremely loud in here for a while. So I'm going to take a break, get some food, and we will be back to get this wire hooked up and put our top cover on, or the dust cover over the brake. Welcome to the next day. It's a little bit quieter now, and we shall continue. So to recap, we've gotten both the motor sprocket and the wheel sprocket replaced. Got the chain installed. We've got the tensioner set properly. We have our brake reinstalled, and I plugged in the cable back there. You just got to kind of look down in there and you'll see where it's attached. Now we're going to put the brake dust cover back on. If you look, there's a little notch here on the front of it, and that's where this cable goes through. Now remember when we took this apart, we've got a couple of little spacers inside here, one on each side, and those hold the bolts in just fine. Makes the installation a bit easier. So we're going to kind of push the cable over like that. Put our brake in the unlocked position. Makes the cover a little bit easier to go on. Make sure that cable's not getting caught. We have our 5/32 Allen. And just like everything else, you want to get all of the fasteners started before you go tightening them down, because it may take a little bit of finagling to get this cover put back on here exactly straight. We are all started. Just make sure that thing's seated properly. Check and make sure it's not hitting the chain or anything over here. Then we can go ahead and tighten these back down. All right, everything there looks fine. We'll go ahead and put our breaker release handle back on here. Just the single Phillips screw, slide it on. Oh, there's a threaded metal insert in there. I didn't see that before. Interesting. So we'll just start by threading that in a tiny bit. Oh, I see. It just presses up against the side of this. So we'll just push this down all the way and then tighten up the screw till it's firmly on there. There we are. And now we have our breaker release reinstalled and working perfectly. And now for the fun part, reinstalling our tire. There's a little bit of a trick to this. If you have the air-filled tires, it's not going to be nearly as much of an issue, but these foam-filled ones are fairly thick. But like I was saying earlier, the bolts that hold these onto the hub are not long enough to go all the way through an uncompressed foam-filled wheel and interface with those threads. So what I like to do is get two similar bolts that are significantly longer. And we're going to use these to get it started. Then we can get it cinched down, put in two of the regular bolts, then pull these back out and swap on the other ones. Now you don't want to just put the wheel on and leave these in there, because these are long enough to interfere with some of the other fasteners back here. So I'm going to pick two of these holes that do not interfere with anything. Looks like these two right here. And the two halves of the wheel obviously need to be lined up with each other, so keep an eye on that. And you can see, looking at the back, these just barely stick out, which will give us enough length to get this thing attached. And being a split wheel and everything, it's going to take a little bit of screwing around to get these to line up. There we go. Those seem to be in there. Then we're just going to run these down and compress the two halves of the wheel together enough so that we can get our regular wheel bolts in there. You do not want to run those in all the way. It's not going to take a huge amount to get it compressed enough for these to fit. And like I was saying earlier, I always use never sees on these. So get this one pushed in, see if we're lined up yet. And I think we are in place there. Yep, we've got that one. Let's do the bottom one. I'm going to tighten these down a few turns. Then we're going to take out these long ones, which should now be loose. And we can replace these two long ones with the shorter ones that actually belong in here. This process also works for the Strikeforce power chairs that have the similarly thick foam-filled tires. I'm going to go around and use my quarter drive impact. I'm not going to rail these all the way down super tight. I'm simply going to get them snug so they're just touching the hub and everything is all pushed together the way it should be. And then I'm going to finish tightening them off by hand. Again, if you're using air-filled tires, none of this is going to be a problem. You can just put the two halves together, put the regular bolts in, and you won't need these longer ones. And of course, you want to go in a circular pattern. Don't just drive one all the way in. You need to do several rounds. And now I'll finish them off by hand. The reason I like to do this by hand is power tools don't give you any sort of feedback, as it were, to how tight things are. And when you're finishing these off by hand, you will definitely know as soon as they bottom out. And I don't want to gall up the threads on everything, because once again, I'm taking this all apart multiple times. So I want to make sure those threads survive. Okay, that feels good. Do one more check here. Okay, that is on there. Throw a little cap on. and I think we're done with this side. I'm gonna grab the jack over here, get this thing off the blocks, then spin it around and do the same thing on the other side. But I'm not gonna record that because it is exactly the same process. So I'll be back once that's done, and we're gonna hop in this thing and go for a rip, see how fast it feels. Yeah, it's a casual 12 miles an hour, I think. The problem with using phones for GPS tracking is they're not super accurate. This is an iPhone 10, so maybe the GPS hardware isn't as good in it. I'm going to switch over to, actually here, I'm going to leave this one running, and then I'm also going to grab my actual daily phone, and I think it should be a little bit better at maybe tracking GPS stuff. It's also very windy out here. All right, I've got my daily phone going as well, so let's see what happens. So there's a slight camber or angle or slope to this, so I can't quite get to full speed, but there we go. That's about 11.6. .3. Yeah, we're hovering right around 12 miles an hour. Nice. And that's crazy because I am way over the weight limit for this setup. All right, sidewalk's a bit unkempt down here, and there's a bunch of crap in the way, so I think we'll turn around. Now, on this particular setup, the weight limit is actually 180 pounds. I weigh about 235, so we're significantly over that weight limit, and we're still able to easily hit 12 miles an hour. So, yeah, I think that's pretty sweet. Now, the thing to also remember with this is it's going to affect your ability to climb hills and also your overall range because we've changed our gear ratios. I'm personally going to be putting this right back to the high speed, which is 8.5 miles an hour, as soon as I'm done with this. I mean, one, because I'm over the weight limit and I don't want to overheat everything and damage stuff. But two, where I live, there's a lot of hills and I need to be able to climb them. So anyways, let's head back and do some more data logging. I'm going to stop real quick and make sure our controller's not getting too warm. Yeah, seems like we're fine. Yeah, as soon as it starts leveling out, I can feel it get faster. Yeah, I can tell this thing's struggling a little bit with my weight. Okay, I'm not gonna lie. That fast in a power chair is a little bit exhilarating. It's still nothing like the chair that they used to make called the Ultimate Power Chair. That one was like 48 volts and went 16 miles an hour. That was truly terrifying because of the speed. This is pretty manageable. So the question remains, should you get this speed upgrade kit? Well, I think what I'm gonna say on that is if you weigh like maybe 150 pounds and never have to deal with any hills whatsoever, I mean, yeah, probably. It'll affect your overall range a little bit. If you've got the lithium battery, I mean, I always use the term loosely, unlimited range, but it's gonna affect it a little bit and, you know, hill climbing and all that stuff. But if you don't weigh anything and you just want to go fast all the time, sure, why not? In my case though, the standard from the factory 8.5 mile an hour setup is plenty for me. Where I live, I have a number of hills I have to deal with on a regular basis. And, you know, Bounder seems to kind of underrate their speed a little bit. Well, my chair came from the factory rated at 8.5 miles an hour. I'm usually cruising at about 9 or so, maybe 9.5. Obviously, it makes a difference how level the ground is. Even slightly downhill, you start going a little bit faster. But in my use case, I'm like 235 pounds. 8.5 is plenty for me. I don't really need to go faster than that. Plus, none of my friends have a chair that can go that fast. So it doesn't really do me any good when I'm out running around. But it's nice to know that the option is there. If you had a Bounder years ago and had the setup that was, 11.5, 12 miles an hour, whatever it used to be, and you want to go back to that, it is 100% possible. Now, Bounder does not have their own in-house electronics anymore. They're using standardized control systems. And in the case of the high-speed chair, that's going to be dynamic links. You cannot get the high-speed chair with RNet controls. And trust me, you do not want RNet controls. The more I've been messing around with different control systems and even on different brands of chairs that use dynamic links, I think it really is the king of wheelchair control systems now. You can do a lot more stuff with this control system. It's a lot easier to program, and you can adjust things like the battery gauge, the braking algorithm. You can even get extremely fine-tuned and adjust the regenerative braking and how powerful it is. So many things that RNet is just not capable of. So if your chair goes above about 7 miles an hour or so, you don't want to have RNet, especially on this setup. Trust me, Dynamic Links is infinitely better. Granted, it does have the touchscreen joystick. Takes a little bit of getting used to, but I think it really is the best option out there right now. We should probably start wrapping this up here. This video is already like 54 minutes long. Anyhow, there are a few caveats with this. Bounders are already fast from the factory. The 8.5 mile an hour version, perfect. You can go faster if you want. Obviously, there's a few give and take things on that, but I'm just happy that Bounder even offers this as an option to people that meet the criteria. It'll be probably a day or two before the abbreviated video is available, but I'm gonna keep that as short as possible, geared towards installers and DMEs, etc. So anyhow, I will catch you guys Thursday on the live stream, and thanks for watching. Hopefully you enjoyed.